We'll next hear from Achim Streit, who is the director of the Steinbook Center for Computing, and he's a professor in CS as well, and he's going to tell us about the German Helmholtz Association.
Okay, thank you for the nice introduction. Thank you also to Ed and all the others from NDS that invited me here to talk about the activities in Germany in the Helmholtz Association and what we are doing there in terms of fostering data-intensive science. So before I start with the content, let me briefly explain to you what the Helmholtz Association in Germany is. So the Helmholtz Association is one of the science organizations in Germany, and its mission is here to do strategic research for grand challenges with cutting-edge research. And our president, Jürgen Lüneck, likes to say, think big, act big. So developing and operating complex infrastructures and large-scale facilities for the national and international science community. So just to give you some examples, Helmholtz is one of the large contributors to the LHC, to other physics experiments in high energy physics and astroparticle physics. In Germany, there are two large facilities currently being built up. A free electron laser in Hamburg at DESY, as well as the FAIR proton and antiproton accelerator in Darmstadt near Frankfurt. You can see here the six research fields of the Helmholtz Association, and in these 6 research fields, science is done in so-called programs. Programs you can think of as large projects that are running for 5 years. They have large work packages in there, and that constitutes the basic funding, the institutional funding for the 18 Helmholtz centers in Germany. You can see here some numbers from Helmholtz. Besides the pure numbers on the left-hand side, so the annual budget, institutional budget is 2.4 billion euro. You can see on the right-hand side a table that shows a comparison to the other science organizations in Germany. So Helmholtz, Max Planck, Fraunhofer, and Leibniz. You can see here in terms of budget that Helmholtz is the largest organization, also in terms of FTE, but not so much in terms of centers or institutes. So Helmholtz has just a few centers, namely 18, compared, for example, to Max Planck, which has several, in that case, 87 small institutes spread around Germany. And you can see here also the various missions of these science organizations. Helmholtz is doing user-inspired basic research with strategic programs. Max Planck is doing pure basic research, so almost every time there is a Nobel Prize going to a German researcher, that one is working in the Max Planck Institute. Then you have Fraunhofer, which is doing industry-oriented research, and then you have the Leibniz Association, which is doing long-term research topics. Here is a map of Germany with the 18 Helmholtz centers, and down in the left is KIT in the state of Baden-Württemberg in Germany. So now let's go to the content. What are we doing at KIT and in the Helmholtz Association to foster data-intensive science? Data-intensive science started more than 10 years ago in Karlsruhe, as well as in the Helmholtz Association, with building up a Tier 1 center for the LHC data. And that one is named Gridcar, and it is one of 12 Tier 1 centers worldwide. And only one of 4 that is serving all 4 LHC experiments here. In addition to the LHC experiments, we are also serving Bell 2, so the next experiment coming up at Keck in Japan, and some smaller high-energy physics, astroparticle physics experiments as well. What is very important for me to say, and those of you who are a bit familiar with the WLCG and high energy physics, the community here, so the physics community is very interested in a high reliability of these centers, so we are constantly benchmarked externally, and you can see here our benchmark reliability of 99.5% throughout the year. In terms of resources, there are some cores for doing analysis and simulation jobs in higher energy physics. These are in the order of 10,000 cores. This is not so much compared to an HPC center, but if you look at data, we have about 12 petabyte net on disk and about 18 petabyte of tape data. Connection to other centers as well as to CERN is very important, and with this infrastructure we are serving more than 20 further tier 2 centers in Germany and the surrounding countries like Poland, Austria, Czech Republic, Switzerland. About 14% of the LHC data is stored in Karlsruhe. So to give you another number, in the last year of operation, right now the LHC is in a so-called long shutdown phase for upgrading it. The LHC produced 25 petabyte of data in that last year. In addition to that, there comes a lot of analysis data, a lot of simulation data to calibrate the detectors and the high-level triggers, and the total amount of data is far bigger than the 25 petabyte. Gridcar is not only a piece of hardware, it's also a lot of services that we are operating here, as it is integrated in a worldwide federation and worldwide data federation. So services for file transfer, regional workload management, file catalogs, this is very important. And also educating people here is quite important, so we are running since now 13 years an annual summer school on modern technologies in federated computing. So about 4 years ago, we started with another facility, which is called LSDF, Large Scale Data Facility, because we found out that there are more communities coming up that have similar data requirements than the high energy physics people. Sort of the problem with the high energy physics facility is that this is money from the community that can just be used for their purpose. So we cannot let other science disciplines on Gridcar. So we had to build up a second facility next to it, and that is serving in principle all scientific disciplines in the state of Baden-Württemberg as well as in Helmholtz. And you can see here a list of the scientific disciplines that we are serving. So this is really crossing a lot of scientific disciplines from typical natural sciences like climatology or also synchrotron research, material science, also up to the humanities, for example. In terms of size, this is currently in the order of 6 petabyte, and we have these funding secured to go beyond 10 petabyte here. What is quite interesting here is that for doing proper data analysis, we have on the one hand side a Hadoop cluster closely attached to the LSDF, as well as a close connection to HPC centers, to HPC clusters in Baden-Württemberg. We have built several services on top of the LSDF, and I've given you here one example of such a service, which is called BW Sync and Share. That is basically a Dropbox solution. Yeah, we heard about that in several talks already today and yesterday. But this Dropbox solution here comes with in a special flavor, I would like to say. So this one is connected to a statewide federated identity management system, which is called BWIDM. And that one allows, in principle, all the employees and students at all 9 universities in the state of Baden-Württemberg, so in the order of 500,000 users, to use this BW Sync and Share facility right out of the box. They can use their account from their home institution. So I'm logging in with my KIT account, and people in Stuttgart or in Ulm, they are using, or in Heidelberg, they are using their university account to log in here, and it just works out of the box. So that one is quite quite unique in Germany to have that combination of a Dropbox-like solution plus plus a connection to a federated identity management system. Of course, also other people outside of the state that are not part of this federated identity, this identity federation can also access that. And we have here a link to the AAI of our NREN, our DFN. And that one is also linking up to the European Identity Federation, which is called EduGain. We also have developed here a so-called LDAP facade that allows to use that allows command line clients to use web authentication. So these are now the facilities that we have. Now let's come to research that we are doing in data-intensive science. In 2012, we have started a project in the Helmholtz Association, which is called Large-Scale Data Management and Analysis, in short, LSDMA. And the idea here is to build a layer between, let's say, the facilities and the infrastructures, the data infrastructures, and the communities. So you can see here on the top, you can see in white the communities, also in white sort of grayed out these facilities at the bottom, and you can see in the middle these blue and green boxes, and one part that we have there are the so-called data lifecycle labs, or in short DLCLs, and these are community-specific teams, sort of tiger teams that are doing joint R&D with the scientific user community. So it's not like that the users come to us and say, we have this and that problem, please solve that problem for us, and then come back to us. So we are doing their joint R&D work with these scientific user communities. And then we have a horizontal layer that is working on generic solutions. So when we find out that more than one community needs a certain solution, we are handing this over to the so-called data services integration team, which is more working on these generalized solutions, for example, in the domain of AAI or archival. Some facts and figures about that project. That is a 5-year running project from 2012 to 2016. In the order of 13 million euro over this 5-year period. There are 4 Helmholtz centers, so KIT, Forschungszentrum Jülich, DESI, and GSI, and then 6 universities in Germany, and also the German Climate Computing Center. In terms of sustainability here, this is a fairly interesting model because we have in Helmholtz a so-called portfolio process, which allows us to kickstart new activities which are, after a positive evaluation, migrated, including the money, into our basic institutional funding. So although this is here a 5-year project, we are aiming for a much longer time period here. And I think in particular in data, this is very important. We are also organizing here our international symposium on the challenge of big data in science. And you can see here some pictures of that. We had Alex Alai with us, or Beth Playley. And the next symposium takes place on the 7th of October this year in Karlsruhe. So if you are interested to visit Germany and Karlsruhe, please visit us. A few scientific highlights from our project. So here, this one is from the Data Lifecycle Lab Key Technologies. Key technologies, you can also say enabling technologies, so that you have basic technologies for other scientific disciplines. And what you can see here in the movie, you can see here the development of a zebrafish embryo. And the benefit of this zebrafish is that it is transparent. So you can simply put it under a microscope and make pictures of it. And in that movie here, you can see the development from a few cells. Yeah, so this is a real movie of, maybe I can start that again. No? Okay. So this is the development from a few cells up to the embryo of this zebrafish. And this was done using novel microscopy technology, in that case a light sheet microscopy. That is actually a picture there. It doesn't look like an ordinary microscope that you know from school or labs. And that one is connected to a data lifecycle processing chain where in the end, with these automatic processing and analysis, not only these films come out, but also you can see here these regions of a zebrafish are marked, and these scientists are in particular interested to track cells in this early development stage of these embryos, so that you can see, okay, now I have a few cells here, let's say 100, and I want to track what comes out of these cells in the end. Is this an eye, or is this a brain of the zebrafish, or whatever? Second example here is from the energy domain. You probably know that that our Chancellor Merkel has announced a so-called Energiewende, or energy change in Germany. All the nuclear power stations will be shut off, and we will go to a large extent to renewable energies, meaning, for example, large windmill parks in the North Sea. The problem is the North Sea is about 600 to 800 kilometers, for example, from the place where I live. And the interesting aspect now is how to get the power from the North Sea down to the southern part of Germany. So there, it is very important to build up the power grid in Germany appropriately to handle these power transfers. And what is needed there is a monitoring of the power grid, because and for that there are used so-called electrical data recorders are used. And what is not so much interesting is how the voltage changes. Yeah? What is more interesting, and that's why they are recording this at such a high rate, which generates about 9 gigabytes of data per day. The interesting part of power is the frequency. So all the directors of computing centers here in the room know that frequency, so how clean your power is much more important than the voltage. So here with this data, technological and economical analysis is done. Another example from climatology here, we have data here from sensors that are flying on high-flying aircraft or on satellites. And here the scientists are interested to have proper databases in place. For example, a NoSQL database, we're using MongoDB in this one project, or to have real-time response analysis frameworks, or to have portals for transport, quality control, and so on. On my next slide, I have included something that is done by my colleague Frank Scholze. He's the head of our KIT library, and he's running a project called re3data.org that is a registry of research data repositories. And yesterday we heard already some talks about repositories. And here the idea of this project here is to gather a lot of repositories in science that do exist. And here in this repository already 634 research data repositories from all over the world are integrated. And for example, also the Pangaea repository that was mentioned yesterday already is also here in this repository. So this was now all science. Now let's look at industry. So we have established a national R&D platform on big data with industry in January of this year, and we are currently in the phase of building that one up, and that is called Smart Data Innovation Lab. This was founded by KIT and SAP. SAP, you probably know that big company, is located about 50 kilometers north of Karlsruhe, the headquarters. And the idea here is to have a place where industry can safely store their data and let people from research apply novel data analysis techniques to this industry data. So this is a benefit for both sides. So the researchers can test their novel web methods with industry data, and on the other hand side, the industry can have the knowledge to, or have the access to novel methods in data analysis. You can see here at the bottom there's a working group on facility operation and tools, so that facility here will be placed at KIT. And then you have also these horizontal activities on Industry 4.0, energy, smart cities, and medicine, with some fairly big companies that are also known here in the US, I guess. There are also some cross-cutting working groups on data curation. We already heard on that, but also, for example, on legal affairs, which is quite an interesting domain when you talk about big data. So I spontaneously put another 3 slides in, and these are about EUDAT. EUDAT was already mentioned in the previous talk, and EUDAT is a European data infrastructure and the objective of that project is to build a cost-efficient and high-quality collaborative data infrastructure, CDI, in Europe. The facts and figures here about that is a fairly large European project running for 3 years with now an extension of cost-neutral extension of further 6 months. So it will be finished in about beginning of 2015 in time for the next so-called Horizon 2020 programs starting in Europe. The consortium here consists on one hand side of national data centers and HPC centers, also technology providers and research communities. And you can see here the logos of all the partners that are involved in the project. So this is a pan-European infrastructure. I will just skip that one and go to the selected services that are developed and operated in EUDAT. In the middle part here you can see the services which are already there in early versions, so about data staging, safe replication, simple store, PID is persistent identifier, so like DOI, and then AAI is also, as well as metadata, is very important. And there are new services to come, so there will also be a Dropbox-like solution called EUDAT Box, or we now have changed the names of these products to B2 Stage, B2 Box, B2 Drop, and all that. So that will be coming up in a few months. So closing up here with the experiences that we have here in Germany, in Helmholtz, and in Europe. Communities' demand for storage, analysis, and archival facilities. We talked about this already yesterday. So they also demand for sharing data with other groups, because they are working in, like we heard in the previous talk, in virtual observatories, crossing countries, crossing funding agencies, and they want to share data there. Data safety and preservation is very important, and they are interested in getting consulting. So the needs are here driven by increasing amount of data, cooperation between groups, policies, open access, open data, as well as long-term preservation. The communities differ in previous knowledge, level of specification of the data lifecycle, tools and services already used. If you look at high energy physics, they're quite mature, they know what they are doing. If you look at people from systems biology 3 years back, they have their microscope and they have their USB disks where they store their data, and that was it. And they simply came to us and said, please help us. Yeah, we have here a data problem. So lessons learned are interoperable AAI is very crucial. Data privacy is very challenging, both legally and technically. So here we are working also together, for example, with lawyers on that aspect. And communities more need evolution, not revolution. That was already mentioned in the previous talk. You really have to work closely with these communities and to take them with you. And the needs of the communities can be very specific, and that is somehow a task of the technology providers of the data centers to finally put this down onto a general infrastructure. And with that, I'm finished. Thank you for the time, and I'm happy to take questions. Thank you.